Use the rational zero theorem to find all real zeros and enter your answers as a comma separated list. Here the function is x cubed plus 8x squared minus 9x minus 72, which is equal to 0. So from the rational zeros theorem, the rational zeros are of the form plus or minus p over q, where p is the factor of the constant term, which is negative 72, and q is a factor of the leading coefficient of 1. So again, the constant term, here we have 72. And then we have 1. So what are all the factors of 72? Well, it's plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 9, plus or minus 12, plus or minus 18, plus or minus 24, plus or minus 36, and plus or minus 72, and that's all over plus or minus 1. So if we divide each one by 1, then therefore these are the possible rational zeros for this function. So we have quite a few that we need to go through. So the first suggestion is to start off by using the remainder theorem. So we can first find the remainder theorem. And so the remainder theorem tells us that we want to find, okay, what happens when we find, let's say, p of plus 1. So if we put 1 cubed plus 8 times 1 squared minus 9 times 1 minus 72. And so this is going to equal negative 72. So we know that p of 1 is not a rational zero. If we want to find p of negative 1, then that's negative 1 cubed plus 8 times negative 1 squared minus 9 times negative 1 minus 72. And that gives us negative 56, so we know that is not a remainder. If we find p of positive 2, we put in 2 and then cube it, plus 8 times 2 squared minus 9 times 2 minus 72, and that's going to give us negative 50, so therefore 2 is not a remainder. And so then we take p of negative 2, plug in negative 2 and then cube it, plus 8 times negative 2 squared minus 9 times negative 2 minus 72, and that gives us negative 39, which also tells us that's not a rational zero. So now if we find p of 3, and that's equal to 3 cubed plus 8 times 3 squared minus 9 times 3 minus 72, and that gives us 0. So therefore, we know that 3 is a rational zero. So if we know that 3 is a rational zero, then we can use synthetic division to find the other ones. So since we know that 3 is a factor, then we're going to use the leading coefficients, which is 1, 8, negative 9, and negative 72. And so from here, we want to be able to find out what is that factor. So we're going to bring down the 1. 3 times 1 is 3. 8 plus 3 is 11. 3 times 11 is going to give us 33. 33 minus 9 is going to give us 24. And 3 times 24 is going to give us 72, which again, we know that we're going to get a remainder of 0. So what does that tell us? Well, what that tells us is that we have the following factors. We know that x, since the synthetic division for 3, we know that x minus 3 is a factor. And then down here, we should see that this becomes 1x squared plus 11x plus 24. So therefore, we can say that this is x minus 3 times x squared plus 11x plus 24. Okay, so what we can do is, rather than having to go through each one of these numbers to determine the next remainder of 0, once we find that first one, we use synthetic division to get this factor. Now we can factor this. So if we want to factor this, we got 24, and then we have 11. So what two numbers can we multiply to get 24? Then when we add them together, we're going to get 11. Well, that's going to be positive 3 and positive 8. So therefore, this factors to be x minus 3 times x plus 3 times x plus 8. Okay, so now that we know that, then we can find out what the zeros are of this. So in the last step, we're going to set each one equal to 0. So x minus 3 times x plus 3 times x plus 8, and we're going to set that equal to 0. So therefore, x minus 3 is equal to 0, x plus 3 is equal to 0, and x plus 8 is equal to 0. So we get x, which is equal to positive 3, x, which is equal to negative 3, and x, which is equal to negative 8. So the zeros of the function are negative 3, positive 3, and negative 8.